Hi everyone, welcome back to my channel. I'm Dinuth. Today we are going to start a new video series on Amazon Web Services, and everybody know it as AWS. AWS is world's most comprehensive and broadly adapted cloud platform, offering over 200 plus fully features services from data centers globally. So millions of customers, including fast-growing startups, large enterprises, and leading government agencies, are using AWS to lower the cost, become more agile, and innovate faster. So out of these 200 plus services, for the today's video, I have selected AWS VPC. When you are deploying your application workloads to AWS, having a properly designed virtual private network is key. That's why I'm making this video to give you the AWS VPC networking foundation experience on architecting and designing VPC for your application workloads with the hands-on tutorials. We'll be designing a VPC for a 3-tier application with multiple public and private subnets, internet gateways, NAT gateways, private and public route table configurations, security group configurations, network address control list, and VPC endpoints during this video to give you the whole bunch of experience that you should have to configure and design your VPC for your application workloads. So without further ado, let's get it started. You have already seen we are going to create all of this network architecture within this video, but I'm not going to explain everything to you at the very initial point. Let's go step by step and understand all of these components in this architecture design. So first of all, we need to understand what is a VPC. Amazon Virtual Private Cloud, or else AWS VPC. This service lets you to provision a private, isolated section of the AWS cloud where you can launch the AWS services and other resources in the private network that you define. Within this network, you can launch your AWS instances, EC2, or Kubernetes clusters, database, Lambda functions, and whole bunch of other services. So it is important to understand this networking service. That's why I have selected this service as my first video for the AWS video series. So this network, it is very similar to the typical network that you find out in your physical data center or else in your on-premises network. So you will have the full control over your virtual networking environment, including the selection of IP addresses, creation of subnets, configuration of route tables, network gateways, and others within the virtual private cloud. And this network that you are creating with the VPC, it will be a regional resource. So if you look at this diagram, you will have an AWS account. In the AWS account, there can be multiple regions. Before creating a VPC, you need to select in which region I am going to create my VPC. So you can pick the region based on the region where you are mostly closer to or else where your application consumers are residing. So here in this example, I have selected US West 1 North California region to create my VPC. Then my VPC needs to have a name, and then you can give an arbitrary name. Here I have given my VPC as my name, and also I need to select a IPv4 CIDR range for my VPC. Allowed block size for the CIDR range is between /16 netmask, which will give you 65,536 IP addresses, and /28 netmask, which will give you 16 IP addresses for your VPC. When you are selecting the IP range for your VPC, you need to first think how many application components will be deployed within my VPC. How many IP addresses do I want within my VPC? Based on that, you can come up with the netmask for your VPC. And then here in this case, I have selected /24 netmask. My CIDR range I'm going to use is 10.0.0.0 24. Once you have decided all of these details, you are ready to go into the AWS console and start creating the VPC. Let's go into the AWS console and then create this VPC right now. Let's search for VPC under the services list and go into the virtual private cloud service. Make sure you are in the correct region where you want to create your VPC. Click on the Your VPCs button and go into the VPC list. I don't have any VPCs at this moment in this region. I'm clicking on the Create VPC button. The VPC name that I want to provide it my VPC. My CIDR range is 0.0.0/24. I don't want any IPv6 CIDR blocks. My tenancy is default. I will be providing the tags here and click on the Create VPC button. Now my VPC is created. You can find out all the details about the VPC here. Now you have the VPC created, but it is not yet ready to deploy your application workloads. You need to create subnets within the VPC that you have created. Subnet is a logical subdivision of an IP network. Subnets has a CIDR range, which is a subset of the VPC CIDR range that you have defined in the previous step. And the subnet cannot span beyond the availability zone. So when you're architecting your application, you need to consider the higher availability for your application. That means you need to deploy your application components at least into 2 availability zones or more for the higher availability. If one availability zone, that means a AWS data center which has isolated power and networking, and if this data center availability zone goes down, you have your same application components running in another availability zone to make your application highly available. So when you are designing your VPC, make sure you are considering at least 2 availability zones or more. Mainly there are 2 types of subnets available. One is the public subnets, where the resources are exposed to the internet through internet gateway. And the other type is the private subnets, where the resources are not exposed outside the world directly. Based on the application structure, you need to come up with how many subnets are required. This diagram shows the VPC architecture for a 3-tier application that we are going to create during this video. It has a database tier which has a RDS Aurora MySQL database, and then it has an application tier which is running on EC2 auto scaling groups, and then it is exposing the app tier components over port 80, and it is exposing these multiple EC2s in this app tier using an internal application load balancer. Afterwards, this internal application load balancer functionalities business tier is accessed by the web tier components which is running in another EC2 auto scaling group, and then let's assume that that web tier is also exposing my application over port 80. Afterwards, web tier components need to be exposed to internet through my public application load balancer. And for the higher availability, I'm designing to deploy all of these components scale through 2 availability zones. In that case, considering these application tiers, I'm going to create 2 private subnets for my DB tier, 2 private subnets for my app tier, 2 private subnets for my web tier, and then 2 public subnets for my public load balancer. So you need to understand that only the public tier, public load balancer will be exposed to the internet, and none of my applications will be directly accessible through the internet, and all of them will be residing in my private subnets. So that is the example that we are going to implement this video, and based on your application, you can decide which components needs to be publicly accessible, which components needs to be only private. Based on that, you need to come up with how many subnets that you want. In addition, for the same kind of application, you can have only 2 private subnets, 2 public subnets as well. But for the higher network controllability, I am going to create the subnet structure in this way. And let's go into the AWS console and then configure these subnets right now. Subnets section on the left-hand panel. and click on the Create Subnet button. First, you need to select into which VPC you are going to create the subnets. You need to select My VPC here. And I can provide all the subnet details under this section. My subnet name is public subnet 1 and my availability zone is US West 1A according to the diagram. My side range is 10.0.0.0/27. I'm adding one more subnet here and providing the name public subnet 2. My availability zone preference is US West 1B. My side range is 10.0.0.32/27. Let me add one more subnet. My subnet name is web subnet 1. Availability zone preference US West 1A. Side range is 10.0.0.64/27. Adding the second web subnet 2. Availability zone preference US West 1B. Side range is 10.0.0.96/27. Now we are going to add the app subnets. App subnet 1. Preference is US West 1A. Side range is 10.0.0.128/27. Adding the second app subnet 2. Availability zone preference 10.0.0.160/27. Now we need to add only the DB subnets. DB subnet 1. Availability zone preference West 1A and my side range is 10.0.0.192/27. Last subnet DB subnet 2. My side range is 10.0.0.224/27. Now we have added all of my 8 subnets that I required for this VPC and then click on the Create Subnet button. You can see all the 8 subnets are created right now and all the details can be found here. Now we have all of our subnets configured. Now the next thing is we need to enable the internet connectivity for my VPC because I have some application components which needs to be exposed to internet. If your application does not need the internet connectivity or you don't want to expose the application to internet directly, in that case you don't need to go through this step. As I want to configure the internet connectivity, I need to create an internet gateway for my VPC. Internet gateway is a horizontally scaled, redundant and highly available VPC component that allows the communication between your VPC and the internet. So this internet gateway, we call it as IGW as well, and this internet gateway is a regional resource. So no matter you have multiple availability zones, you don't need to create multiple internet gateways. A VPC can only have one internet gateway. You need to create the internet gateway and then attach it into the VPC. So let's go into the AWS console and create this internet gateway and attach it to my VPC. Go into the internet gateways section and click on the Create Internet Gateway button. In this case, I need to provide a name for my internet gateway. I'll be providing my VPC IGW and click on the Create Internet Gateway button. Now my internet gateway is created and then you can see the state is detached. To attach this IGW internet gateway into the VPC, click on the action panel and click on Attach to VPC button. Available VPCs, click on the My VPCs and then click on Attach Internet Gateway button. Now this internet gateway is attached into my VPC. You can see the VPC ID here. Now you have the internet gateway attached to your VPC. But Still, we didn't configure the routes for your VPC to send the traffic through the internet gateway. In AWS VPC, route tables are a set of rules that are used to determine where the network traffic needs to be directed. Route table specifies the destination IP address and the target where do you want to send the traffic to the destination. The target can be an internet gateway, NAT gateway, virtual private gateway, VPC peering connection, and many more. But here in this example, I'm creating a public route table, and within the public route table, I need to configure a route to the internet. Internet means 0.0.0.0/0. That means all the IP addresses, traffic to the internet, by creating a rule like this by pointing internet traffic to the internet gateway. Route table can associate with multiple subnets. Here in this example, my public route table needs to be associated with both of my public subnets, public subnet 1 and public subnet 2. When you have an internet gateway attached route table associated with the subnet, and we call it a public subnet. When you have some AWS resources in the public subnets, public internet can initiate the traffic into the resources in the public subnet directly. Here in this example, I have a Bastion server in the public subnet, and this Bastion server can be directly accessible through the internet, as well as that Bastion server can send the traffic to the internet as well. So now let's go into AWS console and then configure the routes for my public subnets. Let's go into the route tables section. You can see for the VPC that you have created, it has already created a default route table. Now let's click on the create route table button and then provide the name for this route table. Let's provide the name public route table, and the VPC that I want to create is my VPC, and click on the create button. This is the route table that we have created. The route table ID is this, and under the routes you can see that it has a default route for the VPC side range. Let's click on the edit routes button and click on add route. Here, according to our routing rules, we need to create a route to the internet 0.0.0/0, and then we need to route this traffic into the internet gateway. And my internet gateway is my VPC IGW, and click on the save routes button. Now my routes are created. I need to associate my public subnets into this route table as you see in the diagram. Public subnet 1 and public subnet 2 needs to be associated with the public route table. Click on the subnet associations, click on edit associations, and select the public subnets here. Public subnets, and click on the save button. Now you can see that my public subnets are associated with the public route table. In our application architecture, we don't want our application components, database, app tier, web tier directly accessible through the internet. What if these EC2 resources needs to access the internet to download the OS patches, accessing YAM repositories to install the applications, or else your application components need to access some services through the internet? So while keeping these resources in private without exposing to internet directly, you can enable the internet connectivity to these resources using NAT gateways. So NAT gateways, network address translation gateways, enables the instances in the private subnet to connect to internet, but prevent the internet from initiating the connection directly into these instances. NAT gateways are available zone bounded. So for the redundancy, if your application components are deployed to two availability zone, you need to have two NAT gateways available in both the regions. And these NAT gateways needs to send the traffic initiated by the private subnets to the internet. Because of that, you need to place these NAT gateways in the public subnet. And also for these NAT gateways, you need to have public IP addresses. You can reserve a public IP address in AWS using the elastic IPs, and first you will be creating the elastic IPs, then you will be creating the NAT gateways associating these elastic IPs. So let's go into the AWS console and make this configuration. Let's create two elastic IPs. Click on the elastic IP section and click on the allocate elastic IP address. Here I'm clicking on the allocate button here. Here I'll be providing a name for this elastic IP. My name would be NAT Gateway 1 EIP. Let's create another IP allocation and let's provide a name NAT Gateway 2 EIP, elastic IP. Now we can go and create the NAT Gateway. Click on the NAT Gateway section. Click on Create NAT Gateway. Let's provide the name NAT Gateway 1. Into which subnet I need to create this NAT Gateway 1? I need to create it in public subnet 1. Elastic IP allocation, NAT Gateway 1 EIP, and click on the Create NAT Gateway button. Let's create the second NAT Gateway as well by going into the NAT Gateway section. Click on the Create NAT Gateway. Provide the name NAT Gateway 2. My subnet is public subnet 2 and provide the elastic IP NAT Gateway 2 EIP and click on the Create NAT Gateway button. If we go into the NAT Gateway section, you can see that both of the NAT gateways are in pending stage. In few minutes, it will be available for you. You can see that now my NAT gateways are created. Now you have the NAT gateways created, but still you don't have the route tables created with the routes to send these private subnet initiated traffic into the internet. So here in this example, I have two NAT gateways. So my DB subnet 1, app subnet 1, web subnet 1 need to send the internet traffic into the NAT gateway 1. And then the other subnets, DB subnet 2, app subnet 2 and web subnet 2 need to send the traffic to NAT gateway 2. That means there are differences in the route tables. As the rules are different, you need to have at least two route tables implemented to make this routing configuration to enable the internet with two availability zone, two NAT gateway scenario. So my private route table 1 will have these rules. Internet traffic 0.0.0.0/0 will be routed into NAT gateway 1 and private route table 2 will have the rules to send the internet traffic to NAT gateway 2. Let's say if the application tier 1 EC2 wants to access the internet to download the OS patches, that traffic will be routed into the NAT gateway. NAT gateway is residing in the public subnet and it has the public route tables configured to send that traffic into the internet gateway, and like that way that traffic will be flow to the internet and the response will flow back into the EC2 back. That's what we need to configure next. Let's go into AWS console and then make this configuration. To create the private route tables, let's go back into the route tables section and click on the create route table. I need to create two route tables, private route table 1. Let's provide the private route table 1 and my VPC is my VPC and click on the create button. This is my private route table 1. First, let's add the routes. When it comes to the 000/0 traffic, I need to send that traffic into the NAT gateway 1. My NAT gateway 1, I'm selecting and then click on the save routes button. Now I need to associate my web subnet 1, app subnet 1 and DB subnet 1 into this private route table 1. Let's go into the subnet associations. Click on edit subnet associations. I need to select DB subnet 1, web subnet 1 and app subnet 1 into this private route table 1. My private route table 1 is ready. Let's click on the create route table button again and provide private route table 2 and select the VPC and click on create. Let's select the private route table 2, click on edit routes and route the internet traffic from this route table into the NAT Gateway 2. And save the routes. Now we need to associate Web Subnet 2, App Subnet 2 and DB Subnet 2 into this private route table 2. Let's go into the subnet associations and then edit associations. Select DB Subnet 2, Web Subnet 2 and App Subnet 2. Now my private route tables are configured correctly. Now we have the basic VPC configured. The next step is we need to secure all of these application components with some firewall rules to control the inbound and outbound traffic from these application components. When you have the database can be only accessible through my application tier components. Web tier cannot directly initiate the traffic into my database. So when you want to control this kind of a scenario, for each application component should have its own security groups configured, and you can make inbound and outbound rule configurations in each security group with the protocol, port, and source and destination IP addresses. One of the important thing about a security group is it is stateful. What this means? It means that any changes applies to an incoming rule will be automatically applied to the outgoing group. That means if you allow incoming port 443 traffic in the Web ALB load balancer security group, that means the request will flow into the load balancer, but the response also needs to be go out in an ephemeral port. So this response going out, you don't need to specifically allow it in the outbound port. If you allow the incoming traffic, it will by default allow the response to go back. And then that will apply to the outbound rules as well. If you configure an outbound rule, it will send that request and the response will come back. You don't need to configure any additional inbound rules to receive that response. Our next step is for all of these application components, we are going to understand what are the required inbound and outbound rules to be configured, and then go into the AWS console and create these security groups and make all of these inbound and outbound rule configurations. We have multiple components in it. We have external load balancers, web servers, internal load balancers, app servers, database, as well as to access these private components. We can have a bastion server such that through that we can SSH and then troubleshoot these private servers that we have in the web tier and app tier. So the best practice is in all of these components, we need to have a separate security group to implement what are the allowed inbound traffic as well as what is the allowed outbound traffic for each and every component. For that, let's create all of these security groups first and then discuss what are the inbound and outbound rules we need to configure for it. Let's go into the security group section under the VPC. You can see there is a default security group there, which is created when you are creating the VPC itself. And then it doesn't have any inbound and outbound rule. The best practice is not to create any inbound and outbound rules in the default security group. Let's create all of these security groups now. Let's start with Web ALB SG. Let's provide a description. Let's create the rules after creating all the security groups. Creating the Bastion security group now. Now let's create the Web SG security group. Now the app ALB security group. Now the app tier security group. At last, we need to have the DB tier security group. You can see the name is not appearing here, so let's do a rename here. Now we have all the security groups. Let's start with the app ALB security group. Our external load balancer should be accessible over internet, over HTTPS by everyone. So in that case, we need to allow all the HTTPS inbound traffic from 000/0. And then once we receive the traffic, this load balancer needs to send that traffic into our web servers. That means the outbound traffic we need to allow into our destination. As the destination, we can provide the web tier subnets as well, subnet IP addresses, but one of the best way is we can provide the security group ID as well as an destination. So in that case, here the destination is WebSG. Now let's configure those rules. We are selecting the ALBSG, going into inbound rules, edit inbound rules, add rule, and we need to add HTTPS traffic from 000. That is our only inbound rule, and we need to have an outbound rule which is sending traffic into WebSG. We can remove this default rule. Going here, outbound, let's say our web servers are serving our traffic on port 80. In that case, we can have HTTP port 80, and here we can provide, rather than providing the IP side block, we can provide WebSG security group here. Now moving into our second security group, Bastion security group. There we need to have only one inbound rule from my personal IP. We don't want to allow that into worldwide. So going into inbound rules and then creating an inbound rule here. The type would be SSH, and then we need to allow only to my IP. In that case, you can find out your IP address from your router or your network settings and then include it here. As an outbound, by default it has an outbound rule into 000, and if you want to limit it into the VPC side ranges, you can remove this rule and then add it. In this case, I will ignore that outbound rule at this moment. Now going into the WebSG, here under the WebSG inbound rules, I need to allow the inbound traffic from my load balancer as well as from my Bastion server into port 80. Here I am creating port 80 HTTPS allow traffic from web ALB security group as well as Bastion security group. In addition to that, I need to allow the Bastion server to SSH into my web servers. Because of that, I am including SSH rule as well, which is on port 22 from Bastion security group. These are my inbound security groups, and then outbound we already have 000, but if you want to allow specifically into our app load balancer as well, let's say when the web server received the traffic to connect into the app tier. So here I'm sending the traffic into, if my app tier is also serving the traffic on port 80, I can send that traffic into HTTP, and then I can send that traffic into app ALB security group. That is my web tier security group. Going back into the security group list and selecting the app ALB security group for its configuration. Here under the inbound roles, I need to configure the inbound on HTTP from my web tier security group, web SG security group. And then as an outbound, I can send that traffic into my application server security group. So here I'm sending the traffic by adding another row, HTTP into port 80 into my app SG security group. Now I need to configure my app SG application server inbound rules. Application server can receive the traffic from the application load balancer as well as from my Bastion servers. So here I'm adding a role into HTTP port 80, and then I can accept the traffic from app ALB security group, and additionally Bastion server can also send the traffic here, and Bastion server can SSH into my app tier components. Here I'm allowing Bastion SG as well. Now as the outbound rules, I need to provide this app tier components can send the outbound traffic into my MySQL database. MySQL database is running on port 3306. In that case, my type can be MySQL. So here adding MySQL on port 3306, and then it needs to send that traffic into my DB security group. Now my app tier security group is configured. Going back, and then at last I need to configure the DB security group that can accept the traffic from app tier servers as well as Bastion server. Going edit, add role, inbound is on MySQL receiving the traffic from app SG as well as from my Bastion servers. That's my inbound roles. As an outbound roles, I already have the outbound allowed traffic into 000. In that case, I have all my security groups configured in the way I want. So in this, based on the scenarios in your application, you can plan what are the inbound and outbound traffic for each and every component in your application portfolio. Now we have the required firewalls created around all of my application resources, and I have the inbound and outbound rules configured to implement the traffic flow between these components. Now the next thing is, can your security groups do everything to implement your firewall concept? As you see here, these security groups were always attached to a AWS resource, but this security group cannot be tied to a subnet. It was attached into AWS EC2 instances, load balancers, databases, and etc. And also, all of these security groups, we configured the allow rules, and then you cannot configure any deny rules in the security groups. So what if you have your application exposed to the internet and you are receiving some malicious traffic from an specific IP address? So in your security group, you have allowed all the inbound HTTPS traffic from the internet, but you cannot apply a deny rule in the security group. That's why a network address control list, NACLs, comes into the picture to help with this kind of a scenario. That's why you should have a network address control list, NACLs, set up in your VPC at the very beginning of your VPC creation. So NACL is an optional layer of security for your VPC that acts as a firewall for controlling the traffic in and out from one or more subnets. You might set up a network address control list with the rules similar to your security groups in order to add additional security for your VPC. And also you can rely on the security groups mostly, but you can have the NACLs configured to cater onto these specific firewall requirements. By default, when you're creating a VPC, it will also have a network address control list created and associated to all of your subnets, and it will have the all allow rules for the inbound and outbound. But here in this case, we are going to create multiple NACLs for my multiple application tier components. And one more important thing is NACLs are stateless. This means any changes applies to an incoming rule will not be applied to the outgoing rule like you have seen in the security groups. That means if you allow incoming port 443 traffic, you need to specifically apply and create an outgoing rule to allow the response to go back in the ephemeral ports. So now you understand the concept. Let's go into AWS and make these configurations. Here in our example, we are going to create 4 NACLs, network address control list, for each tier: public NACL, web NACL, app NACL, and DB NACL. By default, we can have all the allow rules configured. That means we have the rule number 100, which have the allow rule, and then by default there will be a deny rule at the rule list, which is denying all the traffic. We can have these inbound and outbound both allowed, but when the requirement comes up, you can have them configured in the NACL level. Now let's go into the VPC and go into the network ACLs and then start configuring the network address control list. By default, there is a network address control list created, which is associated to all the subnets that you have. And in the default NACL, we can see this 100 all allow, and then at last we have the deny rule. And we have the outbound rules as well configured, which has the first rule to allow the traffic, and then at last we have the deny. That means when the rules are getting evaluated, if the request matches into any of the rule in order, it will stop the evaluation and it will do the allow or deny according to the rule number. So in that case, when you're configuring the NACL rules, you need to keep in mind that you have the rule ordering in place. Now for these 4 tiers, let's create 4 NACLs. Going into create NACL and then provide public NACL, and then selecting the VPC, and here is my public NACL. Here in the public NACL, I need to configure the inbound rule. By default, when you create a new NACL, all the traffic is denied, and then we can add the rule with the edit inbound rules. And here, when we are adding the rule, not like in the security groups, we need to provide a rule number. According to the rule number, it will get evaluated. Here, as we are creating this example, let's allow all the inbound traffic. As well as that, let's go into the outbound rules and then do the same, and then add a new rule and rule number 100, and then provide the allow rule. We can do the same configuration for the web NACL, app NACL, as well as in the DB NACL as well. Creating the DB NACL. And then app NACL as well. Now we have our network address control list configured, but we didn't associate nets into these NACLs. We can go into the public NACL, subnet associations, edit associations, and select public subnets for this public NACL. Save changes, and select the web NACL, subnet associations, web subnets, and app NACL. Doing the same for the DB knuckle as well. Now we have our knuckles configured for our VPC. Your application components are in the private subnets and they might want to connect to the AWS services such as AWS S3 or DynamoDB and other services. When you have the NAT Gateway set up, you will be able to access AWS S3 service without an issue because you have the internet. Through the internet, you can send the traffic into these AWS services. But you have your application already deployed in AWS, and do you want to send that traffic to these AWS services over public internet? Absolutely not. That's why VPC Endpoints comes into the picture, and VPC Endpoints enables a private connection between your VPC and supported AWS services. VPC endpoint devices are scaled, redundant, and highly available VPC components, and there are two main types for the VPC endpoints. Number one is interface endpoints, and the second one is the gateway endpoints. Interface endpoints creates a network interface for the private network connectivity to the AWS service. When you want to connect the AWS service, you need to send that traffic over the private IP address of this network interface when you are using the interface endpoint, as it is creating this network interface. But when it comes to the gateway endpoints, it is associated with your route tables. So the routes are automatically intercepted to send the traffic to the AWS service over the AWS backbone. In my application architecture, my application components wants to access AWS S3. I'm going to create a VPC endpoint for the AWS S3 service to enable this private connectivity. Let's go into AWS console and make this configuration. We can go into the endpoint section, create endpoint. We can search for S3 and we can select the gateway endpoint, selecting the VPC, and I need to select into which route tables I need to connect this VPC endpoint. I need to select my private route tables for this S3 connectivity. Here I'm selecting my private route tables here, and then I'm giving the full access with this policy and then creating this endpoint. So if we look at this endpoint, we can see that these are the route tables attached, and then these subnets will be able to send the traffic into S3 over the S3 VPC endpoint. Right, now we have our AWS VPC fully ready and configured to deploy all of my application components. We have discussed AWS VPC and we configured multiple subnets. We configured internet gateways, NAT gateways, private and public route tables with its configurations. For all of these application components, we understood what are the inbound and outbound network rules needs to be configured, and we configured them in security groups, and we created network address control list for these different subnets, and we created a VPC endpoints including hands-on configurations and the explanations why we taken those decisions when we are designing, architecting, and implementing our VPC for this application architecture. I hope you have enough knowledge with the required depth to design and implement AWS VPC for your application workloads. I hope this video was informative for you. Thank you so much for coming this far. Don't forget to hit the like button, subscribe button followed by the bell sign to get notified when I upload new videos. Thank you so much. See you again in a new video. Until that, bye bye.